Hey everyone, I'm just gonna answer or work through this bend allowance problem I gave you guys the other day. So if you remember, step number one with doing bend allowance is calculating the setback and then subtracting it off the legs. So this is gonna be leg number one, number two, and number three. So the setback on a 90-degree bend is a pretty easy one because the setback here and here is just the inside bend radius plus the material thickness. So the setback on this one is going to be a 1/4 inch plus a 1/4 inch. So 1/2 inch setback. Setback on this one, because we have to calculate using trigonometry for these ones. It's a 45-degree angle here, which means this little angle is a total of 45. So if I cut that angle in half, we get 22.5 degrees. 22.5. The distance from here to here is also a 1/2 inch. It's a 1/4 inch and a 1/4 inch material, so we have a 1/2 inch. Use my calculator. So we have adjacent and we're looking for opposite. So it's a tan function. It's tan 22.5 times 0.5 gives us 0.2071711. So now I can subtract those setbacks. So I need to subtract one setback off this leg because to isolate the straight section here, I subtract that 1/2 inch off of there. So it's 5.5. So leg number one now. Actually, I'm gonna write this up here. Leg 1, 2, 3. Leg number one, 5.5 minus 1/2 is 5 inches. Now leg number two goes from here all the way to here, so we're gonna have to subtract a 1/2 off of this side, and we're gonna subtract this 0.20711 off of this side. So it has two setbacks that has to come off of there. So 6 minus 0.5, and then minus 0.20711 equals, I'm just going to leave this in decimals. So leg number two now is 5.29289. And then finally, our last leg here, we're going to also subtract this setback off of this length. So 4.25 minus 0.20711 leaves us with 4.04289. So those are going to be the new leg lengths. So step number two now is we're going to calculate the bend radius or the bend allowance, and then we're going to add that back in. So there's going to be two bend allowances, bend allowance 1 and 2. And then we're going to add all those up. So if you remember now, if you imagine this as being a full circle and this being a full circle, we're calculating the radius and then just this little piece of pie. Our neutral line is at 50%, so we're only going to that 50% mark because that's where the material is neither stretching or shrinking. Because that's an important thing to remember when you're bending metal. If it's a mild steel or stainless steel, the metal is going to stretch because as you bend the metal, it compresses here and then stretches here, and at some point it's neither shrinking or stretching. Soft metals like really soft aluminum or lead tend to shrink in general rather than stretch, but most of the time when you're doing the bend allowance, it is actually stretching. So that's why I said before too, if you actually, before you even start, if you add up all your leg lengths and your answer is longer than any of those leg lengths, then it's obviously wrong. Because what we're our answer should end up being less than the raw leg lengths added together. Okay, so anyway, for this one here, we're looking for a quarter of a circle, right? This quarter here. So we're going to be using that radius times 2 times pi times angle over 360. Our radius here is going to be a 1/4 inch from here to here, and then we have 1/2 of a 1/4 inch, so that's 1/8 of an inch. So that gives us 3/8 of an inch. So 3/8 times 2 times pi, and then the quarter of 360 degrees is 0.25 times 0.25. Now do that on my calculator. Times 2 times pi times 0.25 equals. So this bend allowance is 0.58905. The decimal goes on longer. I'm just going to round it off. I think that's enough spaces. So this one here is going to be 0.58905. Calculating this bend allowance now. It's a 45-degree angle. So it's the same formula, but this one here, everything's pretty much exactly the same other than the angle over 360. So this time we have 45. So 45 divided by 360 equals 0.125. So rather than having the 0.25, if I go 0.125 here and use the same formula, times pi times 2 times 3/8, that'll give us this bend allowance here. Times 2 times pi times 0.125 equals 0.2945. Two. And now we just add all of those together, and then we'll end up with a total All right, so plus 0.58905 plus 4.042889 plus 5.29289 plus 5 equals, so we have a total of 15.2193. I'm just gonna turn this right into a fraction, so I'm gonna minus 15 and times 16ths, and it gives us 4/16 or 2/8 or 1/4. 15 1/4. So that should be the total for this piece. Now I can double check it. So 6 plus 5 is 11.5. So the 15 3/4. So if I was to add up these raw lengths, there'd be 15 3/4. 15 1/4 is definitely less than that. So I would say we're on the right track. All right, if you have any questions, give me an email or a call. Hopefully that was clear. Anyway, I'll talk to you soon.